AI is everywhere. Farm applications save water by enabling precision irrigation. Recommendation engines help you discover the next YouTube video or Netflix program. Historians use AI to reconstruct ancient texts. If you've ever wondered how AI works, you're in the right place. Welcome to the Data in the Story, where we deploy curiosity as our defense and offense in a fast-changing world. I'm CJ Washington. This is the third in a series of 5 primers that explores how AI learns. Many Data in the Story episodes, from the metaverse to humanoid robots, will touch on AI. And to better focus on the big picture, I'll send viewers here for the details about how AI works. The first primer covered neural networks, comparing and contrasting them to the human brain. If you haven't seen it and you're new to AI, I suggest you watch it now. It provides the foundation for understanding this primer, which is all about unsupervised learning from unlabeled datasets. The second primer covered supervised learning. If you haven't, you'll want to check it out, but it isn't a prerequisite for today. The next 2 primers will cover reinforcement learning and large language models. Unsupervised learning is a key component in many recommendation engines. How does a recommendation engine serve up the perfect video for you to watch next? It needs many things, and we'll talk about 2 of them. First, it needs to know which users you're similar to. Second, it needs to know which videos are similar to each other. Clustering is a tool we use to uncover these hidden similarities. It's an unsupervised learning technique that groups data points together by discovering underlying structure in the data. K-means, a popular clustering algorithm, is efficient, easy to implement, and a baseline choice for many such tasks. Since we've already explored the architecture of neural networks, and because they're really cool, we're going to talk about self-organizing maps. They are a great choice for clustering when we want to take advantage of the nuance between clusters. We want to cluster users, people, but we have to speak the language of neural networks, which is numbers. To represent users, we take a mathematical snapshot of their past behavior, capturing features such as watch history, search history, and their ratings. Each user will be represented by a vector, which is a list of numbers. Our neural network will look a bit different this time around. Instead of a stack of layers, it has an input layer connected to a grid. You can visualize it as a flat map made of neurons. Each neuron in the grid contains a vector of weights, identical in size, the number of values it contains, to the input layer. The input layer is the same size as the input vector, which in our case is the user vector. At the start, the untrained map is a collection of random values, but as it clusters user vectors, it will organize itself into a map where similar users exist in neighborhoods. When we feed the neural network a user vector, the grid calculates which of its neurons is the closest match, called the best matching unit. There are various distance metrics that can be used to calculate similarity in vector space. Euclidean distance measures the straight line distance between vectors in space. Cosine similarity measures the angular distance between vectors. Ideally, we want a distance metric that best captures how closely the neuron mirrors the user's viewing habits. Once a neuron is chosen as the winner, the user vector is said to belong to that neuron's cluster. And then the magic begins. The winning neuron adjusts its weights to become an even better match for the user vector, but it doesn't act alone. It pulls its neighboring neurons along with it, though to a lesser degree. This creates a ripple effect where neurons physically close to each other on the grid become mathematically similar. Over time, as we process thousands of users, the random grid transforms into a meaningful landscape where distinct communities emerge, not as isolated islands, but as connected neighborhoods. We might find a cluster of users that prefer humorous videos. Right next to it, in the same neighborhood, we might find users who enjoy political satire. Another neuron down, moving smoothly away from humor, the landscape might transition into users who prefer serious political commentary. Recommendation engines might do user-based clustering, as we just saw, item-based clustering, creating the same type of map with video vectors, or likely a combination of both. That way, it can take users similar to you, show you a video they like, and then follow up with more similar videos. You're probably thinking right now that unsupervised learning is pretty cool. But what if you want an algorithm to learn through experience with the world? Tune in to the next primer on reinforcement learning. Keep your curiosity strong, and whatever you're curious about, I hope it leads you back here and I hope you find what you're looking for. Do you wonder how reinforcement learning works? Or maybe you're asking, what is reinforcement learning? Subscribe, turn on notifications, it's coming to the data in the story.